Hi Year 11, I hope you're all well and having a lovely week at home. We're going to carry on our work today on simplifying surds, looking at a couple of new skills today, but really mostly just combining different old skills that we already know how to do. Make sure you've got a date and title, and as ever I would suggest you're making notes of these examples in your blue book, and maybe when I just sort of do the second example of a set, you might see if you can pause it and have a go after you've probably just watched the first example. That second example, see if you can pause it and have a go, and then you can watch it back and see how you did. So it's going to start off by looking at adding and subtracting surds. Now adding and subtracting surds is very much like when we add and subtract different letters with algebra. I can't add root 44 to root 99 in the same way that I can't add an x to a y. They have to be matching. But usually if we're given two surds to add, it should mean that we can simplify them to make it to ones that are matching, so we can add them. So first I'm going to have a look at root 44, which I can see has a factor of 4. So I know it's the same as root 4 times root 11, which means it's the same as 2 root 11. Then I'm going to have a look at root 99, which I can see has got a factor of 9. That means it's the same as root 9 times root 11. And I know the square root of 9 is 3, which means it's the same as 3 root 11. And as I said before, really, this is just like adding algebraic terms. Root 11 I can treat just like an x. 2 root 11 plus 3 root 11 is just saying 2 lots of root 11 plus 3 more lots of root 11, which means I've got 5 lots of root 11. And that's all there is to it, really. Going to have a look at this one. Once again, I've said this before, said this in previous lessons, always look for the biggest square number that you can get into it. 180 has 4 that goes into it, has 9 that goes into it, but the biggest square number that goes into it to make our lives easier is 36. So just like before, I'm going to park the 2 on the side. Let's draw a line down there so that's nice and clear. Park the 2 on the side. 2 and root 180 is the same as root 36 times root 5. Root 36 is just 6. So it's 2 times 6 times root 5, or 12 root 5. And I'm going to deal with my root 45 now. 45 has just got one square factor, and that's 9. So root 45 must be the same as root 9 times root 5. And I know the square root of 9 is 3, so it's the same as 3 root 5. And then once again, it's just like before. I've got 12 lots of root 5. Take away 3 lots of root 5 means I've got 9 lots of root 5. So pause the video there and have a go at questions 11 to 12. Spend about 15 minutes on those questions. Obviously, if you finish it in less than that, great. But once you've spent about 15 minutes on those questions, come back to the video for the next part. Okay, hope you got on that okay. Make sure your work all made sense and you marked your answers. Now we're going to look at expanding single brackets. And as I said before, we're not doing anything totally new here. We're just combining things we already know how to do. Hopefully you're feeling quite confident on your surd laws by now. And so I just readjust the camera. And we're just going to combine that with expanding single brackets, which we're already very capable of doing. So just like expanding any single bracket you've expanded before, I'm going to do the thing on my outside of my bracket times the first term, and then add on the thing on the outside of my bracket times the second term. So root 5 times root 2, we know, is root 10. And I've got root 5 times 3 root 5. Well, I know that root 5 times root 5 is just 5, or root 25, which is just 5. So I've just got root 5 times root 5 is 5, times 3 is 15. So it's just root 10 plus 15. This one's just got slightly more on it, but not much different. Maybe pause the video now, see if we can have a go at it. Okay then, so we've got 4 root 3 times root 12. Well, I know that root 3 times root 12 is root 36. So that's just going to be 4 root 36. Now I think I can do something more with that, but I'm just going to do the second term on my bracket first and then come back to it. 4 root 3 times minus 2 root 6. Well, 4 times the minus 2 is minus 8, times the root 3 by the root 6 is root 18. But actually I think with both of my terms I can make them a bit better, because I know that root 36 is just 6, and 4 lots of 6 is 24. Now 18 isn't square itself, but I'm pretty sure it's got a square factor. I'm always looking for those square factors, and it's got a factor of 9. So it's going to be the same as 8, just park the 8 there, not going to worry about the 8, come back to that in a minute, times root 9 times root 2, because I know that root 18 is the same as root 9 times root 2, and root 9 is 3, leave my 24 there, so I've got 8 times 3 times root 2, or 24 root 2. Obviously we've got two 24s there, but that doesn't really mean anything. I've just got 24 minus 24 lots of root 2. Have a go at those single brackets, and you won't always get these bang on. There are lots of different things going on here. Sometimes there are different roots you can do. Sometimes you can root things first, okay? So don't expect to get everyone perfect, but that key sort of core concept of just expanding those, even if you can't get right into the tricky ones, you won't all get all the way down, but just making sure you're just doing this times this and this times this as best you can. So spend about 10 minutes now on question 13 and then come back to the video. Okay, I hope you've got an okay with question 13. If you've really struggled with question 13, then I would just say spend another 5 or 10 minutes on it, or even if you need to go back slightly, okay? This next section now I would say is just for people that have been quite confident. You might have finished everything in the 10 minutes and the 15-minute slots, okay? If you really struggled with any of those things, I wouldn't worry about this section. Still spend another 10 minutes, but go back and spend 10 minutes practicing something a bit further back. Oh, sorry, there goes the bell here. Okay, but for those of you that are still with me, that were quite confident on all the ones we so far, we're going to look at double brackets. And just like before with double brackets, this is exactly the same rules as when you multiply double brackets in algebra. I'm going to do first 2, outside 2, inside 2, last 2. So my first 2, 3 times 8 is just 24. Outside 2, 3 times minus root 7 is, well, 3 times root 7 is 3 root 7. So 3 times minus root 7 is minus 3 root 7. Inside 2, root 7 times 8 is just 8 root 7. And last 2, root 7 times minus root 7. Well, I know that root 7 times root 7 is 7. So root 7 times minus root 7 is going to be minus 7. And just like with the brackets, we already know how to factorise. There's often bits I can simplify here. I've got 24 minus 7 is 17. And I've got minus 3 root 7 plus 8 root 7. Well, that's going to be 5 root 7. So nothing really new here, just combining double brackets we already know how to do with some of our surd stuff we've worked on. Here's one more example. Have a go at it now if you want. Pause the video, see how you get on. Okay, so I'm going to do FOIL again. First 2, root 20 times root 3 is 3 root 20. Now one point I was going to make here is actually some of you may or may not have spotted that root 20 can be cancelled down initially, and you could do that and still do it, and some of you might find it easier. Because my numbers are all quite easy here, I've chosen to leave it as root 20, but if you wanted you could simplify root 20 and actually it might make that bracket a bit simpler. I'm just going to leave it as is and cancel it down at the end. My outside 2 is root 20 times minus root 5. Well, I know that root 20 times root 5 would be root 100, so it's going to be minus root 100, which obviously I can cancel down, but I'm going to come back to that after I finish this first step. Inside 2, root 5 times root 3 is 3 root 5. And last 2, root 5 times root 5 will be 5. So root 5 times minus root 5 is going to be minus 5. Once again, there's loads of simplifying I can do here. 3 root 20, well, I know that root 20 is the same as root 4 times root 5. Oh. Thank you for your patience. And root 4 is obviously 2, so it's 3 times 2, so it's 6 root 5. Square root of 100 is obviously 10. 3 root 5, I can't do anything with that on its own at the moment. Oh, 3 root 5, and then obviously minus 5. I can't do anything with that on its own at the moment. But now there's even more simplifying I can do. 6 root 5 plus 3 root 5 is going to be 9 root 5. And minus 10 minus 5 is going to be minus 15. So a lot of cancelling down I could do on that one. That's about as tricky as you could expect it to get in higher tier. So a bit of an extension there. Have about 5 or 10 minutes on question 14 if you've got this far, marking as you go. Hope that's all good for you. Have a lovely day, and I'll speak to you tomorrow.